Here we are then in lighting experiments land again. Now, it's not always immediately apparent when something is going to be especially useful, but it is always worth noting when things don't behave how you think they're going to behave, and it sort of helps you understand better what's really happening. So at the moment I've got things set up so this is a default sky, and because it's the default sky it'll be coming with an intensity of 90. I'm going to set that up at 100, even though it seems unlikely that I'm going to be using any direct light sources. What we've got here is ground plane default grey and Stanford Dragon, and if I look at the material on that you'll see that it looks red, but if I go into the menu that shows you the RGB constituents, so hold the Alt key down and click on the colour swatch there, you see it's full red, a bit of green, a tiny bit of blue, and if you've seen the tutorial on hue shifting then you'll understand that when I do a TA render and if you start to see it shift from the red to the yellow, then you know that you're meeting the maximum light capabilities, and if it turns to white then you know that it's maxed out and been capped. So that's just diffuse on the surface, otherwise it's a very simple material. For lighting I'm going to go to the atmosphere off, set it to fully black. This sky dome colour is fully black. We've got no ambient in the scene, and I'm going to turn off the sunlight, so at the moment no light. Then go into render options, premium effects, I'll set that down fairly low, 16, true ambience, TA scatter correction boost light, I'll set the value at 4 for now. Render again, still fully black, which is good. Create a light source, so I've created a radial light. I'm going to enlarge that so that it sits around the dragon, but it's, we'll be able to see where it intersects with the ground all very well. And I'm going to edit that so it's true ambience optimized. Now for rendering scene we won't get anything in here because you don't see true ambience optimized. Renders in there, and I'm not going to set anything else for the time being. So let's see what that gives us. Right, so you can see due to the boost light we've got quite a bit of noise in here coming from surface acting as a light source. So this is one of the reasons why in the obscure lighting approach, where you light it from the inside, it has the advantage of not having this noise issue. So if I now increase this output to the diffuse, I don't need specular, and it's getting the colour value from here, then you'll see that it's got a bit brighter. We've still got these very bright points in there, and that's a bit of a problem for us. I'll take it up to 200 and it becomes brighter still. So what happens, okay, if I'll edit this and I'll use the influence control to include only the background. Now nothing's named as the background at the moment, and so if I render this now we're back in dark, but if I rename this light source background, can it light itself? Well, in this instance no, so I'm going to modify the material now, so it's not this material which is the default state of a light material. I'm going to set it to the default grey material. So can it light itself at this stage? No. Maybe though it's because there's not enough light, so I'll increase the light so we've got a lot of light now, and I'm going to turn off the fall off to none, so if that makes any difference, and we'll see whether we can light that. Still no. So okay, right, modify the material now. So this is the material of the radial light, but when it's TA optimized, the surface of the light becomes affected by this material property, and I turn the diffuse off. In fact, I'm going to set it to fully black. Set the ambient to black, specular to black, halo to black, transparent to black, volume to black. I'm going to set the reflection up. So now it's a mirror, but the mirror is only reflecting, it's not responding to any light, so it can't become a light source. So why, when it's a mirror, does this happen? This is strange behaviour. So somehow, even though it's excluding itself, the TA is picking up light from somewhere on that object, because it's not in the environment, nothing else is providing any light. So this is very odd behaviour, interesting behaviour too. As you can see, quite a lot of light. So I'll edit this again, and you'll notice I've not had to use gel to set the material up. You can do, it just gives you an easy way to get through to that button, but we're doing it in a way to limit other things. Now if I turn to linear, will that significantly reduce the amount of light? No. So there's not much difference between linear and none in terms of fall off. Squared though, it will respond to, so that's changed things a bit. Still getting quite a bit of noise. You can see on the ground here that the edge is very bright, and so it has some fall off property and through this reflection. So other things about the reflection, well, we'll finish fiddling with these and just set the value down. I don't know, I'll try 200 so that it's in a range where we can interpret the results. So there we go. So we've got here where it's turning yellow, we know that it's started to get towards the capped out area, and then it's quite dark there. If it's using reflection from its material property, again this is the radial light surface, it should mean that I can use, say, the diffuse property here. Now I've changed that to blue. I don't expect to see any change here yet, and as expected there's no change, but through metallicity, because that affects reflected light, we get some of the blue. Now the important thing here is through metallicity, at other angles, like at shallow angles, it does reflect all the colours, so it won't be totally blue, it won't be like a blue filter, but it will affect the light at certain angles, as you can see that now, blue, but we're still getting some white. Obviously it's reduced the response in the material there, so that's an interesting thing. So it does show that it's the reflective surface it is responding to. Right, I'll just kill that again now. So what differences can we make to this reflective response now, having used the metallicity to demonstrate it's definitely the reflection that's doing it? The fact that it's a sphere means that, and it's the light source as well, and somehow it's seeing itself, means it's got some peculiar optical properties, because in a sphere the tangents to the, or is it the normals to the surface? The normals to the surface will be all pointing in towards the centre of the sphere, so it's going to have some optical properties that probably result in this light distribution. And so I thought we can use the render options here and use blurry reflections to break up the way the light's being scattered around inside this sphere, because it must be captured or gathered, I should say, since we're using TA, and being affected by the reflection. Now reflection forms images, TA's image neutral, but by combining the two, then obviously we're getting some imaging properties. But you can break that up to some degree if we modify the material properties here, take the specular halo up to a value where it's going to start having an effect, say about 200. That should blur the response. So you can see now some of the more of the light getting scattered in towards the middle, and out we're suffering with a lot of noise issues. And we can raise the raise per pixel, we're still going to have noise issues with boost light. We could always lose the boost light. Right, I'll turn it up to maximum specular halo, and that'll give maximum light scatter. You can see now it's become a lot brighter, and the lighting's quite even inside. So this is obviously a combination of transience that's working with the diffuse surfaces and the light scattering that's working with the mirror, but the light gathering process must be gathering in from the outside of the mirror somehow. I don't know how it's working, it's just something I've uncovered this morning, and I had an idea and decided to test it. So it's early days yet, but I thought it was interesting. What is more curious still? Right, go into material properties and set the specular halo down to fully black. So that'll give us back the sharp image that we had before. What happens if we add bump? Now that could be, this is my theory, a bit like the specular halo blur effect, because if I had a bump in here, and I'm going to use, well, any old bump pattern as it happens, but it does have to have some bump. If you do the bump effect without bump, hang on, it's Camtasia's messing with the menus again. Right, here we go, we've got some bump output there, so give it some bump, so we've got some bumpy spots. Is when you add bump, it amplifies the light. It amplifies the light a lot, not just as much as you would expect from the scattering, and bear in mind with bump you can increase it to 998 positive, or have minus 998, and that's creating a lot of light from this effect. So that it's interacting in a way that I don't really understand there, but it does work. And if on this component, if we get rid of the bump by choosing none, then it does revert back to its original state. So it's definitely a reaction to the bump height somewhere that's creating this effect, and it doesn't matter what it is as long as there's some bump there. It seems to be fairly even in its response. Actually, if anything, that looks a bit brighter than it did before. So on the light output of this, I'll drop it down to 1 and we'll see whether there's anything there. Yeah, a significant amount of light there, and I can't really go below 1. I'll drop that down to 100 on the bump height. Still a lot of noise. I'll drop it down to 1. I'll probably kill the light altogether. Yeah. So it seems to ramp up quite a lot. Maybe it's not a linear response. So you can see, although it's very noisy, that the lighting on that is very even. Now, to deal with the noise, we can go back to non-boost light, but the results are not really as nice, and it's looking quite dark. So I'd like to stick with the boost light but get around this noise issue. So I'll switch boost light back on. There we go, and I'll edit this, and I wanted the material actually. Edit the material of this, get rid of the bump situation. So we've just got the reflection, and then increase the light intensity. Oh, one thing I didn't demonstrate, and I suppose I should at this point, put the light back up again, see how we're looking with that. Okay, you see the ground here that's white, well, it's within the default grey material. That's the mirror. I'm going to edit the light source, and if I change that to green, for example, just to show that the colour is definitely coming from that component there. So that's putting a green output. Now that green must have got some blue component in there for it to create that effect. So back in here, if I make sure that this is fully green without any other of the components, once again this is the hue shifting effect, we'll just get a green output from that, and that can only then respond or work with the material channel green, because it's a very pure colour. But obviously that creates a bit of an artificial situation in the rendering environment. It's probably an effect best avoided unless you're using it for a special effect, since such pure frequencies don't occur without using lasers or things like that in real life, right? So I was going back to pondering the situation of the amount of noise we've got in here and what we could do to combat it. Well, probably the only thing we can do is increase the rays per pixel, which is going to reduce the render time. So, sorry, increase the render time. So that's 12-minute render, which isn't too bad, but it's obviously suffering from all the extra reflections. The other thing we could do is change this plane material so that it hides the transition where this light is, because obviously the proximity of the surface of the light is creating these strong bright areas. So if I modify this material, and I'll use the material that I made for the Anisotropic, where are we going? Somewhere in here. Not seeing the channel at the moment. Oh, there it is. The anisotropic water effect. There you go. So that could work with the blurred reflection, and this will also work with the light gathering, and it'll start gathering from this surface. So if instead of just black here was to make that a strong green tint, then that will show up somewhere on the model, here on the top of the model, because the light that's more, let's see, it's more perpendicular to the surface gets tinted. So this creates an interesting effect that the green from the reflection on the ground there is getting incorporated onto the top of the model. The other things to play with would be the maximum ray depth. So if we start at 1, which is going to be faster rendering, you can see that there's no reflection, and it's just the initial light that's travelled through the system by whatever route it does so at the moment. I say it's still a bit mysterious. It's obviously something to do with what it counts as excluded. Right, that's 2. So you can see now there's a bit of green under the chin there, and obviously some further interaction. And 3. So this has changed the characteristics quite a bit. So there's a point at which when you start adding more ray depth, it doesn't actually add anything else much to your render, so you can see a bit more light at the time, and you could go on like that. So there's something else to investigate there. So I might try, because there's a sort of a harshish transition here, the bit more meddling with the specular halo on the material properties of this. So if I set the specular halo HLS, I'll try 150, see if that affects much on there. So it just transits it a little bit further around the corner there. Material, I'll try 180. The blurred reflections, they don't seem to do much below 150. It's not very noticeable. There you go. So that's moved things around a bit. By choosing the higher rays per pixel, it's combated the noise somewhat, and this has turned yellow but not white. Eventually, if we provide enough light, it should eventually just turn white on the outside edge there, because of the capping effect. See the hue shift tutorial for that one. So all in all, a bit of an experiment, nothing really conclusive, but as I was saying, I think what happens is when you include or exclude something, oh, look at the render time, 21 minutes, then it knows on the first instance that it encounters that object, but it seems that with the reflection it's lost the association, and then after it's reflected it's no longer associated with the object that it's supposed to be ignoring. It's a thing in itself within the render system, and then can be seen by the light gathering method of transience. This is my speculation. I don't know if this is the case. I may be completely wrong, but that's the idea. So I suppose really that's the end of the tutorial, even though it's not really a proper tutorial. Probably we'll come back to looking at this in the future after I've experimented with it a bit more and seen if it's actually useful for anything. I mean, at the moment it's quite an interesting effect with this very bright transition zone. It almost looks like the light's coming through the back of the model there, like subsurface scattering, which would be really nice if we'd got it. But that's on another topic now. So I'll pause the video here and we'll have a look at this at the end of it. I can already see there's going to be quite a bit of noise in there, and call that it. There then is the completed render. It didn't take as long as it thought it was going to, or it predicted it was going to, probably because when you start incorporating transience with reflection, its processor usage becomes a bit unpredictable, and its method by which it anticipates how long the render is going to be taking is thrown out by that. So I think it took about 10 minutes in all, so about half the time it was predicting it was going to take anyway. So there you go, an interesting effect and the end of another experiment.